Okay, so typical question on the test. You get this and they say, what are the possible roots? Now you might be able to be smart enough and just graph it and know what the root is, because we're going to allow you to have a calculator. But you wouldn't get the question right that says, what are the possible roots, unless you know this little formula. This is called the rational root theorem, and it's the factors of the constant over factors of the coefficient. And the factors of the constant are 3 and 1. And the factors of the lead coefficient, well, there's only one number there, so it's just the number 1. And then dividing by 1 isn't going to really do anything. So in this case, it's just 3 and 1. And don't forget plus and minus that. There's your answers. So I'm going to write them in order from smallest to biggest. -3, -1, 1, and 3. Now, those are the possible roots. Which one actually is it? You'll be able to use a calculator. Instead of having to do all the grunt work of having to test all of those with synthetic, I'm going to say, look, which one do you think it is? Looks like it's -3. Now, would you use synthetic, though? Well, yeah, because you need to factor it. You can't just say, yes, it's -3. You have to factor it with that. So everybody right now, try synthetic with that and see what it factors to. I'll pause for a second while you give that one a try. All right, so hopefully you put in a 1, a 3, a 1, and a 3, and you drew a line, and then you dropped it like a tot. Multiply, add, multiply, add, multiply, add, and you got a 0 at the end. Is that significant? Yes, because that means you have no remainder. And then you should be able to interpret this now. X plus 3, and what does that mean? That, and that. X squared, 0 what? 0x, and then what's that 1? Plus 1. There we go. And should you factor it further? I strongly recommend it, because kids that can do this are the kids that are going to get the roots right. Because that's an easy root. That's the harder one. If you think this part through, you'll be able to do the cool kid factoring, as I've been calling it. X and plus and minus and square root of 1. Uh-oh. I'm about to make a dumb simplifying mistake. What is the square root of 1? 1. You always do the square root of that number, but when the square root works out nice, you use that. And then, again, take a second and check it. If I multiply that out, that doesn't work. So what does it need, TT? Eyes. Like eyeballs. See, like this. No, it doesn't need that kind of eye. It needs I for imaginary. There we go. X plus I, X minus I. All right. Then when they ask how many real roots did this have, we would say what? 1. And if you looked at the graph again, do you get that the real roots are the ones that where it crosses? It only crosses the x-axis once. One real cross right there. Okay. Does it still have a total of 3 answers? Yeah, 2 of them are imaginary. That comes from this little dipsy-do thing there. You don't always actually see the imaginaries, because you can't like identify a spot on the graph that has this, because it's imaginary. But I can tell you it only touches once for real. All right. Then, blast from the past. Do you remember when we had graphs like this, and this is touching at -3, and this is hitting at 8, and you had to write equations for it? Try to remember how to write the equation for that. Okay, C. What do you think? Y equals, Chloe?
So, I will compare it to
Take a guess at what you do with this.
X
You're right. And squared. Very good. It's because of how it interacted at the x-axis. That bounce there gives it the squared. How many of you knew that was squared? Okay, good. If you didn't know that, take special attention. This is part of our unit. And that is an 8, but it's not a plus 8, it's a minus 8. Why? Because that thing's called a 0. When we stick it in, we want it to make the equation equal 0, so it's x minus 8. And that did not cross in any special way. All right. Did anybody even look to see that it was going up and therefore it's positive? If that crossed your mind, you get credit for that. But do you get, if it had been going down, you might not have noticed and might have forgotten to put in the negative? All right. So here's another one, and this one's got all 3 kinds of roots. Let's see if you can identify all 3. All right, this function is down on the left and it's down on the right, and it's hitting right here at 0 and right here at 10 and right there. I should use red for that. 1 second. This is 10. Use red for this. And let's say that that's at 15. Would you please write an equation for that one? There's a single root, a double root, and a triple root. Pay attention now to how they're touching the x-axis. So Bob, who's not really very good at this, but Bob says, okay, well, I know there's a 0, so I'm going to put x plus 0. And I know there's got to be a 10, so I'm going to say x. Ooh, and he's actually got this right, that you can't use regular 10. He's going to say minus 10. And he's going to say x minus 15. So that's not a bad start for Bob, but he's definitely going to get it wrong. Help Bob out. Yes? There should be a negative in front. How many of you guys caught it? There's a negative. It's so easy to forget. Just have to look at the right side. If it's going down, it needs a negative. Okay, how about this? There's something else wrong. In the back? Yes, because why? Very good. That's a bounce. Those are worth 2. Think about a parabola back in the old days when a parabola would just touch once right there. Parabola's row is squared. Okay. Could you have argued, well, that parabola could go like that too? Yeah, that's 2 single roots. And that's also worth 2. But it's 2 separate single roots. All right. Then, there's one more thing. Bob's not going to get this right unless you give him a little bit more help. Yes? It is to the third. How many of you noticed that this was doing that special kind of a triple root? Now, I give you permission. If you look at a graph and you're like, I can't tell by looking at this if it's doing that thing or not, and I'll talk you through it on the test. And what I'd say is it increasing the whole time? Yeah, it is increasing the whole time through here. But did it change how it's increasing? Yeah, it was increasing, and it was getting like slower and slower, and then at that moment it changed to faster and faster. Okay, so if it's going from slowing down to speeding up, then that's a triple. Okay, cool. Most of you would have got that right. Now, I'm going to give you one more that's talking about something we haven't talked about in a long time. If I said that was at 4, 2, and I said this was at 1, 3, that would make those 2 points kind of special. Well, they have special names. Know what they're called? Nobody's going to get this one right if I gave the test right this second. Yes? There are turns there. Can't argue with that. You're right. But it's a name that indicates that it's a special spot when it comes to like being high or low. Yes? Yes. And you can either say relative max or local max. Which one of these two is a local max? That one. That one's a local max. What's the other one? Or a local or relative maximum. The other one, that one is a what? Minimum. Local minimum, local or a relative minimum. This one has no max. A common mistake answer is that the maximum is infinity. We don't say that. We say it doesn't have a maximum. It just keeps going up. How about on the downside? Does it have a minimum? No, this graph does not have a minimum. All right, then here's the killer. List all of the intervals over which the function is increasing or decreasing. So I'll give you a simple one to start with. Do you get it's going down in that little zone right there? How do you officially say that it's going down from there to there? Do you list the whole points? Nope, you get it wrong. How do you say that interval? Well, I like to think of it this way. It's from here to here that it's going down. I'm going to make like little dotted lines just to show you what I mean. Like from this like little fence post here to here, that's the zone where it's going down. I missed a little bit. I'll drag it over there. But that's not something you can say on a math test. That's just me trying to explain it. In that little zone between the two dotted lines, that's where it's going down. Did anybody write from 1 to 4 with a parentheses? That was the right answer. It's been like a week and a half since we did it, but that's called an increasing or decreasing interval. And notice I used the x numbers from the points. I used the x's. And now how about this? I'm going to move the green zone. No longer talking about in that little zone. Now I'm talking about in that little zone, the zone between the two little stripy dotted lines. What's it doing in that zone? It's increasing. Describe the interval over which the function is increasing. Got it? Okay. I'll pause for a minute while I give that one a try. Okay, I hope you said that it's increasing from 4 to, well, when does it stop increasing? Never. 4 to infinity. Raise your hand if you had said 4 to infinity. Okay, awesome. Now this next one is more challenging. I don't know if some of you can do it. Be ready to step up. Oh, yep. 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 Okay. So the argument is this. At the 4 itself, isn't that the lowest spot that it ever got here? Like, so therefore it wasn't actually increasing yet until it goes past the 4, and so the 4 isn't included. And then the reason we don't ever put brackets on infinity is you can never get there. So you'll never touch infinity. It's like you're reaching for it, but you can't get there because it's always a little further away. Okay, so that's why we use parentheses. I get, you could actually make an argument that like if it didn't start at 4, then where did it start, increasing? So we have to use the 4. But anyway, so I could even live with you putting a bracket on this, but never put a bracket on infinity because you will never touch it. Yes?
I was wondering, on the left side
Yep.
of the 1, 3.
Yep, what's it doing in here? How about if I move this?
Oh.
I'll move this over, and I'll say, all kinds of things just went wrong. Hold on just a second. Computer's super slow, and so it couldn't keep up with me, which is really sad, because I'm just a mere human. Okay, from here to the other pink line, nope, from here to, just a second, come on computer, there. From here to there, what's it doing in there? It's increasing. From where to where? Well, how far over did it start increasing? Negative infinity until it stopped increasing at the 1. Okay. All right. You know what? Judging by the number of questions in that one, I'm just going to do one more like that to make sure you got the idea. Let's say that your function did this, and it went down to a low spot here of -2 comma -1. And my question is, list the increasing and decreasing intervals. Label the increase with INC, label the decrease with DEC. Make your increasing and decreasing intervals for this one. And judging by how long this is taking, I think you're getting the idea why I'm glad we're not testing on Monday. There's a lot of topics on this test. One thing that's kind of unusual then is on your homework, I don't care if you do evens or odds, just do something like that. Actually, this is a rare time to not be an overachiever and do the whole worksheet like tonight and tomorrow. Because otherwise, then on Sunday and Monday and Tuesday morning, you won't have done any math, and then all of a sudden, boom, it's a test. It'd be smarter to divide the homework up into 2 parts. Do some tonight and tomorrow, and maybe even on Sunday, whatever. Just do a few this weekend, and then on Monday, do some more. So that on Tuesday, you're all fresh, and it's been recent. It didn't do it all on Friday night, and now it's been 3 days, and I forgot everything. Okay, yes. So I hope you said increasing interval would be from there over, which is an x thing, and therefore it's from -2 to infinity. The decreasing interval, where was it decreasing? I'll draw it in blue. This is where it was decreasing, and that would be from -infinity until it hit -2. How many of you got them right this time? Okay, good. Now I'm ready to stretch you then. You know how Jeopardy gives you the answer and you got to figure out what the question was? The answer to this one is this graph increased from -infinity until it hit 4, but then it decreased from 4 to 6, and then it increased again from 6 to infinity. Draw it. Now, there's more than one way you could do this. There is more than one right answer. That doesn't mean everything's right. Because I never told you how high it went. On a graph where they give you the graph, they're telling you how high it goes. I never said how high it goes. So you get to decide. As it's increasing, how high does it get when it stops increasing at 4? The 4 is not the height. The 4 is the x. All right, I'm going to pause for a second. Let me give this one a try here. Okay, so on this one, I gave the kids the increasing and decreasing intervals, and then I asked them these questions. What was the x value at the local minimum? What was the right end? What was the left end? And that red graph or the green graph would have been an okay way to draw it. It doesn't really matter. You could have drawn it a lot of different ways. But the x value would have been 6 at the local minimum, and the right end is up and the left end is down. Okay, that's all I have for that. There's more review coming on a review video on Monday because the test isn't till Tuesday. That's all I have for the video for today.